Are you still using the Singleton pattern? Today I'll show you why this may not be the best idea, and what to do instead. As object-oriented developers, we should know the Gang of Four's design patterns. While this seminal book is now 30 years old, its content has stood the test of time. These patterns are still important now, but in particular the Singleton pattern has seen better times. Of course, the pattern never got worse. It's just that we have better alternatives now. So join me in this video and let's take a look at this ancient pattern, its downsides, and how a more modern approach helps us to get rid of those. Welcome to Frankly Developing. I'm your host Frank, and let's start with a quick recap of the Singleton design pattern. The purpose of this pattern is to ensure that there's only one single instance of a class and to provide you easy access to that instance from anywhere you want it. And finally, to control this instantiation process of the class so no one goes around creating a second one. But as I said, the pattern has its downsides. Let's take a look at a recommended implementation here. This one is in Java and directly from Wikipedia, which is no coincidence. Whenever I wrote a new singleton, I always referred back to such verified examples, because as you can see, this is not particularly easy. Here's the getInstance method to provide the easy access to the singleton object. Inside you find the recommended double-check locking approach. First we check if the instance is already present, and only if not, then do we get a lock. And if we have it, we check again. The second check is necessary because multiple threads may be waiting for that lock. We do not want multiple instances to be created from that. And the first check is mostly for performance reasons, because acquiring that lock just to return an already existing object is quite expensive. And then there are the really subtle things like the volatile keyword here. It is necessary because the memory write order may otherwise write the reference to the new object before any writes are made to the fields of that object, for example by its constructor. This in turn leaves a raised condition where another thread may be able to access the newly created object in an uninitialized state. Horribly complicated for something as simple as ensuring that there's just one instance, isn't it? And that's already one of the downsides of the Singleton pattern. It is surprisingly hard to get right. And also don't blame this on the Java programming language. For example, John Skeed in his book C# in Depth gave 6 different implementations for the Singleton pattern, only 3 of which are actually safe to use. And another common objection to this pattern is that it violates the single responsibility principle. The singleton is supposed to be a class with some responsibility, but it also has to take care of the other responsibility of ensuring its own singletonness. And finally, it leads to an annoying coupling. Imagine any piece of code using this via singleton.getInstance. And now you want to unit test that code. It's really hard to control the dependency on the singleton. What if you don't want to test with a real thing? What if you want to use a mock instead? And you better never want to change that to use different instances in the future. Of all the problems I encountered with the many legacy code bases I've worked with, getting rid of a singleton like this may well be the hardest. I never succeeded to do it on any significantly sized code base. Let's see how this plays out in practice in a modern fashion. So this is just the default template that you get for creating a new C# solution. It's just an endpoint with a weather forecast example here. But what we're looking at is how do we realize a singleton. And for that we now have the dependency injection available, and we can add a singleton just like this. And now this singleton here, it's really just a simple class. And the .NET framework in this case will take care of all the rest to make sure that there's only one instance of this class available to you at runtime. And the same thing works for other dependency injections in other languages, like Spring Boot, etc. Before we go into explaining why this is such a game changer, if you like this kind of discussion and demonstration, please let me know in the comments below. Feel free to subscribe to the channel and like the video. It would help me a lot. Thank you very much. Now, why is this so much better? Let's take a look and extend this a little bit to demonstrate its effectiveness. Let's say that my singleton has some property that we want to access. I know, like some shared counter or something. So maybe just a counter property. And I know this is not a good design in general because it's a publicly writable, essentially global variable, right? Just to demonstrate the purpose of using your singleton and being able to access it. Now, in this case, I have this counter, maybe it's initialized to like 10, and it can be used now in other classes. So if I have another class that is like service kind of thing, I could use the dependency to the singleton in the constructor and basically keep a reference to that singleton available. And in some method, I could use it, and yes, in C#. Okay, simplify this to this one here. But here in my method here, basically, let's make it something passable. Let's just say we use this and have it return this counter. Now that's just a normal singleton usage, but in contrast to the singleton.get instance, we now actually get a instance to the constructor, which kind of loosens this coupling. This problem of having a hard coupling is now loosened a lot. And you can notice this if you write a unit test, for example, for the service. So let's just pick a unit test here. We need that. We can move some other stuff we don't need here. Very simple. So let's say we have an instance here of our service. We can create that. And now we need to specify the singleton. We can't use the other singleton for the unit test. We can just create another instance here. It's not a runtime thing, so this instance is just the one instance for the unit test scope, essentially. So this is perfectly fine, and we can work just like with the classic singleton pattern. Let's take the service and say something, and then we can say something like the foo method should return out of 10, and that'll be fine, right? But now we use the actual singleton code, so we don't really have a way to replace it in the traditional singleton pattern, but now we can just pass in a completely different object. And that works just like the old one. But now what we can do here is we can actually factor this and extract an interface where we include the counter. And all of a sudden, it's easy to bring in mocks and dummies and anything else of that nature. So you could write a test singleton that implements the same interface. Initialize the value to 13, for example. Like, yep, we should use it here then. And the service needs to be defined on the interface. Sure. But now we have the option to work it as in a more traditional object-oriented sense. Right? So we have all these standard mechanisms in place to just replace these dependencies for the testing, which is just the beginning, because you can imagine in a bigger code base, eventually you may not want to have that singleton in all the places. Maybe there are different areas where you want to use different instances eventually, and then you have the option available. Like you could also derive from the singleton clause, etc. Like all of these things are working. But this is why it's so much more powerful, because now this coupling is loosened up a lot. And this whole downside of the hard coupling is pretty much gone. It's very easily replaced now and decoupled to use a different object, as you can see here. And if you take a look at the implementation of our singleton, It's also much better in terms of the single responsibility principle. There's nothing else going on here than what the singleton is supposed to do. There's no more singleton-ness code or responsibility needed at all. And last but not least, like this is much simpler, right? So you don't have the risk of messing up the implementation and creating a lot of problems. So there we have it. The singleton pattern as defined by the Gang of Four is no longer what I would consider state of the art. Instead, you can use your dependency injection framework to achieve the same effect while significantly reducing the downsides. I already explained how the downsides are improved upon, but let's revisit the purpose of the singleton once more to see if that works as well with dependency injection. We want to ensure that there's only one single instance. Well, sure enough, the DI framework does that for us. We wanted to provide easy access to that instance. Again, the DI framework allows that easy access by simply declaring the dependency. Finally, we wanted to control the instantiation. While the traditional pattern makes the constructor private, our DI framework needs to be able to call it. So in theory, anyone, anywhere, could just instantiate the class directly. Simply using a dependency injection framework thus gives you 2 out of 3 of the benefits and reduces the downsides a lot. In my experience, the third purpose isn't that important in an environment that relies on dependency injection. You normally don't even think about directly instantiating these classes. But if you're really worried about that, then you can usually fix that by limiting your DI offerings to interfaces and reduce the visibility of the implementation classes to only the place where you set up your DI. I hope you enjoyed this quick update on a 30-year-old pattern. Thank you very much for watching, and as always, have fun developing.